We're going to be talking today about the what, why, who, when, and how of software requirements. This presentation is going to discuss, as I said, the what, why, who, when, and how. We'll talk about what requirements are, the various levels and types of requirements that need to be defined for your software-intensive systems and projects. We're going to talk about the why getting software requirements is such an important part of software development projects. If you don't get your requirements right, it doesn't matter how well you do everything else. You can do a perfect job of building the wrong software product. We're going to talk about who needs to be involved, identifying your software requirement stakeholders, getting the right people involved in your requirements activities. We're going to talk about when those activities should occur throughout the software development lifecycle. And then briefly, we're going to talk about how to do requirements engineering. Basically, the major activities of requirements elicitation, analysis, specification, and validation, along with requirements management. So what are requirements? Requirements can be defined as the statement that identifies the capability, something the software has to do, or its characteristic or quality factor, something the software has to be. For example, it has to be safe, or it has to be secure, or it has to be user-friendly. Of a system in order to have value and utility, now Young says to a user. I like to expand that and talk about requirements to all of our stakeholders so that we think outside the box of just our users. For example, you yourself are a stakeholder of your software systems, and you may have requirements around things like maintainability, supportability. There may be other stakeholders like government regulators who are not directly users of your system, but you have to meet their requirements, obviously. So it's anything that has value or utility to any stakeholder. It's a stakeholder need, necessary feature, function, or attribute of the system that can be sensed from the outside of the system. You should be able, with black box testing, where you just treat the system as a black box, put inputs in, look at the outputs coming out from very much a user perspective, you should be able to test that all of those requirements have been met. You can sense them from the outside. If it's anything internal to the software, that's where we're getting into the design and code. The one exception to that is design constraint type requirements. If you have a requirement that you absolutely have to design or implement a system a certain way, then it is a design constraint type requirement and it breaks this definition. For example, Department of Defense used to specify that all software had to be written in Ada. That's a design constraint. You're never going to be able to sense that from outside the system. You've got to actually go in and look at the code. Or you may have a requirement that a certain encryption methodology be used or a certain algorithm be used in your calculations. Again, those are design constraints. They're the exception to this rule. But most of your requirements should be able to be sensed and tested from that user perspective, from a black box functional perspective of testing your software. I actually like Somerville's definition. I like to think of requirements as the three whats. What the software has to do, a description of its behavior, those functional type requirements. What the system has to be, its properties, its attributes, those quality factors, things like safety requirements, security requirements, reliability requirements, maintainability requirements, those properties or attributes. And finally, those design constraints we talked about. The what constraints are there on the choices the developers get to make when they implement the system. So requirements are the three whats: what it has to do, what it has to be, what restrictions are there on the developer's choices. Now, many people talk about their software requirements as if they're all one big thing. You know, here's the requirements. But I like to drill on down from that and think about the different levels and types of requirements. Sometimes when I'm talking to a stakeholder, I'll hear something clear up at the business level, a very high level requirement for the system. The example I like to use is the pay at the gas pump system. Everybody's done that. You're all familiar with paying at the gas pump for your gas, an automated software-based system. So at the very highest business level, the business requirements are what the software does for the business. For example, a business requirement would be to be able to collect payment for the gas out at the pump. High-level business requirement. You may also hear lower-level stakeholder requirements. These are from the perspective of those individual stakeholders. What does the system have to do or be for those stakeholders? A single business requirement, like be able to collect money out at the pump, may break down to many stakeholder level requirements depending on the stakeholder. For example, if we think of the perspective of the driver who's driving in and purchasing the gas, they want to be able to scan their credit card, they want to be able to get a receipt, they want to be able to select the gas type, pump the amount of gas that they want, those types of things. So those would be stakeholder level requirements associated with that single business requirement. Now if you look at a different stakeholder, for example the owner, they want to make sure they get paid. So their requirements are going to revolve around making sure the credit card is validated before you let you pump any gas. There may be requirements around making sure that the payment actually gets credited to their merchant account, those types of requirements. There may be also requirements for the attendant of the gas station, that stakeholder group, wanting to make sure that any alarms or notifications come to them. Make sure that they can pull those pumps outside in case you come in and pay and want to buy Tootsie Rolls and things like that as well on your transaction. So the stakeholder functional requirements are the things that the stakeholders need to do with your system. Now if I told you go scan a credit card or do the software to scan a credit card, most of us probably couldn't program that. We'd need a lot more detailed information. So those high-level stakeholder requirements, which is what your customers and other stakeholders are going to ask you for, have to drill down to what does the product actually have to do. These are the software level or system level functional requirements. For example, that one of scanning the credit card may come down to requirements around what interface data is coming from the hardware, the credit card reader, how to parse that information into the credit card number and other fields, what information to send to the bank, what codes are coming back from the bank and how to interpret them. So there's going to be a lot more product level requirements, so there's a hierarchy. And sometimes you actually hear product level requirements from your users or your other stakeholders. Other times they're up at the stakeholder or business level. Now at the stakeholder level we also have business rules. These are rules about how the stakeholders are allowed to interact with the system. For example, going back to the pay at the gas pump, recently we were pumping gas on our way back from a long trip and we hit the stakeholder level business rule that you can only pump $100 worth of gas on a single transaction, and you can't use the same credit card more than twice. Now I run into this because I've got a big pickup truck that has not only a 30-gallon gas tank but an auxiliary gas tank, and prices for gas on our trip were much more expensive than they are here in Dallas, so we waited until we got back to fill up. In fact, we were running on fumes. But we ran into those types of business rules. All of your government regulations are also business rules. And those will filter down into more detailed functional requirements. What does the product or system or software have to do in order to implement those business rules? Now, have you ever had a user ask you for a user-friendly system, or they want it to be fast? Those are the quality attributes. Again, they're not specific to any individual requirement. All requirements have to be safe. All requirements have to be fast, each feature and function, for the system to have that quality attribute. But how many of you know how to program user-friendly? You know, that's going to very much depend on the different users. What's user-friendly for a novice user may drive a power user nuts. For example, think of the little paperclip guy that used to pop up in Microsoft Office. Didn't you love him? Not if you'd used the system for more than a few days. On the other hand, my father-in-law, who is a very occasional user, just thinks that's the greatest thing. He thinks it's very user-friendly. Drives me nuts. But those quality attributes, again, have to be drilled down into product-level requirements. Now, the software being user-friendly may drill down into functional-level requirements, like having a help function in your software. Or they may drill down into what are called non-functional requirements. Now, folks, this doesn't mean they don't function. They're not non-functional. What they mean is they're not specific to any single function. Like I said, every function or feature has to be safe for the system to be safe. Every function has to be user-friendly for the system to be considered user-friendly. So they're non-functional because they're not specific to any function. A user-friendly example of this might be that the system will respond to all user commands within 3 seconds. Even if it's that little hourglass or that little moving dot, just something to tell the user that the system is working so they don't start pounding on the keys. You may have other non-functional requirements, for example, accuracy. All monetary transactions in the system will be rounded up to the nearest penny. Or you may have reliability requirements. For example, when I used to work in telecom, we had a reliability requirement that we weren't allowed to have more than 3 minutes of unplanned system outage per site per year. Whatever those are, they cross multiple functions. Now, some of your requirements come in at this product level. For example, how are you going to talk to other software systems, other hardware systems, the external interfaces to the outside world? Typically those come in at a product level, to the level of detail that you can actually implement the software to those requirements. Those design constraints, by their very nature, since they are inhibiting how you're going to implement the product, they are product-level requirements. Use this certain encryption methodology. Use this certain programming language. And you may have data requirements. Now, again, we're not getting into the design at this point. We're not trying to say it has to be saved as a floating point or a date format or it has to be so many characters. Leave that to the designers if you can, unless it's a design constraint. But what we're looking at here is certain pieces of data that have to be collected and used in the system. For example, again, the pay at the gas pump system. For each transaction, you're going to have to save the credit card, probably the date and time of transaction, the amount of gas pumped, maybe what pump it's pumped on, the total dollar value of the transaction, etc. And all of these requirements, no matter which level or which type, are going to be documented in one or more requirement specifications. Now notice I put the S on there. I have seen this where all of this is in a single document. The business level requirements are Chapter 1. The stakeholder requirements are Chapter 2. The product requirements are Chapter 3 through N for however many. I've also seen it distributed across multiple requirements documents. For example, your business requirements may be in a project charter or a statement of work in a contract. Your stakeholder requirements may be in user stories if you're an Agilist, or use cases. We used to have a separate marketing requirements document at that level. Your product requirements may be in a software requirements spec or a system requirements spec. And I've even seen it where data requirements are broken out in a data dictionary. There's individual documents for each of your external interfaces. How many documents this is up to you. And how that documentation is done is also going to be a choice that is made. For example, with many modern tools these days, if you get a requirements management tool, there is or there may not be a separate requirement spec. Each requirement may just be an entry in the tool. In fact, one of the big advantages of that is you can take your business level requirements and actually link them through hyperlinks in the tool to the lower level stakeholder down to the lower level product requirements right inside the tool and start doing your traceability of your requirements. And of course, if you go to the pure Agilist, these may be documented as 3x5 cards or sticky notes up on a wall. It may not be a document in the classic sense. So there's many different ways of specifying these. But I do want you to think about the fact that you need these, need to be thinking about the different levels and types of requirements as you're doing your requirements engineering information. Now, to just give you some examples here of quality attributes, I've talked about a few of them. This is kind of my list of the ones, my checklist to remind myself to think about these. You have usability requirements around how user-friendly or the ease of learning of your system. You have reliability requirements around the mean time to failure or the number of failures per period of time. Availability is kind of the inverse of reliability. Is the system there when I need it? Or you might talk about the availability of support for your system. Do you have a help desk that's open 7/24? Or is it only open from 8 to 5 during normal business hours? Performance requirements, things like throughputs, response times, capacities of your system. Efficiency requirements usually relate to the utilization of computer resources. For example, what percentage of memory or disk space are you allowed to use? Efficiency many times relates directly to interoperability. If you're a bandwidth hog in your system, then you're not going to be interoperable with other systems that have to run on the same computer at the same time. Security is all about keeping security attacks. People that shouldn't be in your system but are trying to get into your system, keep them out of your system, or if they get into your system, limit the amount of damage they can do. For example, different levels of privilege or different things that can only be done in certain periods of time, encryption of information, keeping an audit trail so that if they do get in, you can see how they broke in and potentially plug that hole for the future, and of course being able to recover if they do get in and do damage, backups, those kinds of things. Safety is all about the ability of your system to detect and or prevent accidents or recover from accidents. Accidents are anything that can harm or kill a human being, damage or destroy property, have negative impacts on the environment, and so on. I'm not going to read all of these through to you, but I wanted to emphasize these a little bit because many times in requirements engineering, I see people paying a lot of attention to what the software has to do, and they miss defining requirements that are the quality attribute type requirements and drilling them on down to non-functional requirements. And I've seen in this day and age more systems die because of lack of usability rather than lack of functionality. There's just so many choices these days. People just won't use a system that's not user-friendly and so on. So I wanted to get you thinking about these other types of requirements. So shifting on to the why. Why are requirements so important? Frederick Brooks, and he's one of my gurus from way back when, if you've ever heard of the mythical man month, adding people to already late software projects makes them later, that's a Brooksism. But Frederick Brooks, his quote that I just love, the hardest part of building a software system is deciding precisely what to build. No other part of the conceptual work is as difficult as establishing the detailed technical requirements, including all of the interfaces to people, to machines, and to other software systems. No other part of the work so cripples the resulting system if it's done wrong. No other part of the work is more difficult to rectify later. Folks, if we don't get the requirements right for our systems, it doesn't matter, as I said, how well you do everything else. You can do a perfect job of building the wrong product or a perfect job of building what you have specified, but when it gets in the field, it doesn't work the way they need it to work. It doesn't meet the actual user's needs. One of my clients calls them the oopses. Oops, we forgot about that, and we want to keep that from happening. Why are requirements so important? The Standish Group went out and did a survey of project and program managers, and they found 5 out of the top 8 reasons that projects fail directly related to requirements. First of all, those oopses, the incomplete requirements. You just forgot about something, it didn't end up in your product at the end. Lack of user involvement. We think we know what they want. We don't actually involve all our stakeholders, and we'll talk about that when we get to the who. Who do we need to involve in these requirements engineering? Now, number 3 is lack of resources. It's not directly involved with requirements, but I submit to you that it's very indirectly related, because the requirements are the scope of the system, and we're going to do our project estimates, staffing, resource allocation, and things based on that. So if we don't have all our requirements, if we don't do a good job of understanding the requirements, we're not going to allocate enough resources. Of course, unrealistic expectations from the stakeholder community. They think we're selling them a Rolls-Royce. We think we're building them a Volkswagen Bug. If we don't do a good job of specifying and agreeing and understanding and getting the ambiguity out of our requirements, they may think they're getting something very different than what they are, and that'll cause the project to fail. Because how many of you have problems with changing requirements and specifications? You're halfway through the project, you're maybe even into testing, and all of a sudden things are changing. Now, change is inevitable. The Agilists recognize this. In fact, we've all recognized this for years. But we can minimize a lot of the unnecessary change because of the oopses. If we don't discover the oops until testing or the field, we're going to have all this churn and change. We want to make sure we've got a good solid set of requirements up front. That will dramatically decrease the amount of change. But on the other side of the coin, we've got to be doing good requirements management and adopt and adapt to those changes in stakeholder needs. For any project that's more than about 6 months in duration, we're going to have some significant change. And if we don't adopt and adapt to that change through good requirements engineering practices, the system we deliver at the end, they just may not need it any longer. It may not meet the user's needs. One of the ways I like to talk about this or think about this is using the Kano model and adapting it slightly. If you went out and think of the last time you went and bought a car. You went into your car dealer and you specified a set of requirements. Maybe you wanted a sedan that was 4 doors with leather seats and a good sound system that was safe and reliable, had a great maintenance history, good resale value. These are the expected quality requirements. These are the expected requirements that the customers are actually going to tell you about when you go and talk to your stakeholders about what their requirements are. If you don't meet any of those, the product will be considered poor quality. You'll end up with a very dissatisfied customer, and they're not going to buy your product from you if you don't do what they ask for. The more of those you meet, the more satisfied they're going to be. Hopefully, eventually they'll buy your product and be a happy customer. Now, I submit to you that no matter how many times you talk to your users or stakeholders, or if you were the car salesman, talk to the person purchasing the car, they're not going to ask you for certain things. They're not going to ask you for a windshield. They're not going to ask you for a steering wheel. Did you ask for a steering wheel the last time you bought a car? Why not? Well, because you just expect it to be there. It's not a car if it doesn't have a steering wheel. Those are the basic requirements, and you're never going to be able to, quote-unquote, ask the customer, what do you want, and get those basic requirements. They just expect them to be there. The reason I emphasize this is because my lessons learned, I've missed some of those. We tend in the software arena to know software. We've been trained in programming languages. We've been trained in development, in design, but we haven't necessarily been trained in our user domain. An example I'll give you of this, I was building a energy management building automation system back in the day, and our customers requested a special customized billing package and paid us a bunch of money to do this for them. And I was the person assigned to this. It was early in my career. One of my big lessons learned I never forgot. And I, quote-unquote, did everything right. I interviewed them. We even did requirements, architectural and detailed design reviews with the customers. I built prototypes and showed it to them. We had extensive acceptance testing. Everything went well. They loved it, installed it over the weekend. Now this was Minneapolis, Minnesota in January, so it took about an hour to install the system, and I'm looking around going, I don't want to go out in that 3 feet of snow. So I said, what else can I do for the customer? And I happened to know he was a one-finger typer, so I volunteered to type in his database for him of all of his customers in this energy park. We were doing great till we hit the American Red Cross. What's special about the American Red Cross and a billing system? If you think about it for a minute, maybe you thought, well, they're a charity, therefore they're sales tax exempt. Well, yeah. And my customer looked over my shoulder and pointed at the screen and says, where's the field to make the American Red Cross sales tax exempt? And I said, you never told me that was a requirement. Oops. Folks, you've got to be paying attention. You've got to know enough about the domain that you're building things in. You've got to train your software people in enough of that domain that they're not going to have those kinds of oopses. I sold him a car without a windshield, a car without a steering wheel. Nobody's going to be happy. Notice all of these are down in the unhappy region. If you give them all of their basics, it doesn't make them happy, it just keeps them from being more and more unhappy. You give somebody a car without a windshield, they're going to be real unhappy real fast. And of course, added to that are the exciting requirements. These are those innovations. Again, your customers aren't going to tell you about these, but if we're not being innovative, if we're not always thinking about the next thing, the next features, functions, characteristics that makes our product better, we're soon going to be out of the marketplace. We have to have that domain knowledge to understand that as well. Think about the first time you had a cup holder in your car. Did you ask for it? No, but wasn't it neat? And it was exciting, and of course, what happened the next time? Did you ask for a cup holder? Or did it make it all the way down to the basic requirements and start being an expected part of the car? So exciting requirements are only exciting the first time, but we have to think about those different types of requirements. Now, who has to be involved in the requirements engineering process? If you look at the capability maturity model integration from the Software Engineering Institute, one of the generic practices is to get the key stakeholders involved. This is nowhere more true than in the requirements process. You've got to identify those key stakeholders and get them involved in the requirements engineering process. So when we think about who are our stakeholders of our software product, the first ones we usually think about are the people that are acquiring our software. Now notice I use the term acquirer because I break that down into two groups. There is a difference between customers and users many times. I'll give you another example from early in my career. I was working on a system for an Air Force base, and I had a procurement officer, again, did all the right things with that customer, got all of their requirements met with the system, etc., but when I went out in the field and installed that system and had the users come to me and say, we don't want it, our union is fighting it, we're never going to allow it to be installed, I had another major oops. You know, I'd forgotten about the fact that there's a difference between customers and users, and you need to get the users involved. The users can kill your system even if the purchasers buy it from you. You end up with shelfware, software that nobody ever uses, even though it's been purchased. Now, sometimes the customer and user is the same person. I bought Microsoft Word, I use Microsoft Word. But for many other systems, the customer may be an IT group or someone in management or, like I said, a procurement officer, different from the people that use your software. I also break users down into two groups. The direct users are the people that actually lay hands on your software system, the people that are going to interact directly with that system. On the other hand, there are indirect users. Indirect users are the people that use the information that come out of the system. Going back to that pay at the gas pump system again, the company accountant may be an indirect user that is using the information from the pay at the gas pump system to be able to do the monthly sales tax reports. Some executive from corporate management may be an indirect user that gets sales reports out of this system. You've got to be paying attention to those stakeholders and their requirements as well, or you may end up with systems that don't have the right information or reports coming out of them that those individuals need. On the other side, the suppliers of the system are also stakeholders. You yourself, as developers of the software system, have requirements. For example, requirements around maintainability, testability, supportability. Have you ever noticed that in Microsoft Office there's always a way to go in and pull what version and revision and service pack is installed? That's a supportability feature. That allows the help desk person, when the users in the field call in with a problem, they can have the user go to that field and find out what version, revision, service pack are installed and go from there. There may also be distributors of your system that are different from the developers of your system. Now, some companies actually have a development group separate from the group that is releasing the product to the field, supporting the product in the field, within your own group. Or that may be a separate company even. When I worked energy management and in building automation, just to describe that, we were the developers, but we sold our software to value-added resellers, i.e. the construction companies that built it into the building. But the customer were the people that were paying to have the building built, and the users were the maintenance people inside that building, the people that were actually running the energy part of the building. So we had very different stakeholder groups. You need to identify these. And then, of course, there's other stakeholders. People that are neither on the acquirer or the supplier side, anybody that might be impacted by or impact your system. For most of you, many of you may be in a government-regulated industry. The regulators are other stakeholders. They're not on the acquirer side. They're never going to use or pay for your software. They're not on the supplier side. They don't build it or distribute it. But they have a very big impact on your system and its use. Another example might be, for the pay at the gas pump system, the firemen, who need that big all stop button. So if you back into the pump and knock it over and catch it on fire, like my husband did once upon a long time ago, you can run over and hit that all stop button and doesn't spread the flame around the fire station. So you've got to be thinking about who else might be impacted. This may even be your own marketing group or legal department or other organizations. So think about all those stakeholders. Because now, why do we want to think about all these stakeholders? As Gauss says, perhaps the single most common mistake in the development effort is leaving an essential person out of the process. If we forget about the stakeholder, we forget about their requirements. If I'd have just thought about the charities, I wouldn't have missed the sales tax exempt requirements. As soon as I think about them, I remember that. Of course, it also gives you that broader experience base. You're never going to know as much about the processes that your software is supporting or the work that your software is supporting as the users and customers will. So by involving them in the process, gaining that domain knowledge from them, learning how to ask the right questions, getting them to teach you about their domain, you may even discover not only the basics but some exciting requirements by talking to them about how they use or need to use the system. Gives you a lot of different perspectives. The users may have different needs than the customers. The regulators are definitely going to have different needs and requirements than the suppliers. It also results in more buy-in. The system that I talked about for the Air Force Base was a complete disaster because we didn't involve those users. We just involved the customer, the procurement officer. And I know the system was never used because I'm good, but I'm not that good. And I know in 2 years that I continue to support that system, quote unquote, we had one problem report, and it was a misspelled word on one of the introductory screens. So it just wasn't being used. It eliminates, by involving these stakeholders, it eliminates the two worst ways of trying to get your requirements and doing requirements analysis. As Carl Wieger says, you don't want your developers to have to try and be clairvoyant or telepathic. You want to actually talk to people and find out what they really need, what they really want this system to do. But if you haven't guessed by now, there can be bazillion stakeholders in a system. Going back to the pay-at-the-gas pump system, you may have stakeholders that include the people that are selling Slurpee syrup or Tootsie Rolls inside the gas station, providing those products. They're stakeholders. If you're not coming in and paying for gas, you're not doing point-of-sale impulse buying of Slurpees and Tootsie Rolls. So while they're impacted, you can't necessarily talk to everybody because the list is too huge. Again, going back to the CMMI, it says key stakeholders. So once you've got the list and thought about the complete list, you're going to want to prune it down. And my first take at pruning it is who must we include? What stakeholders must be included in the requirements engineering activities? We got to talk to the owners of the gas station. We've got to talk to somebody representing the attendants of the gas station. Who must we include? Who would we like to include if we have time? And this starts becoming a prioritized list, because if everybody that must be included, we're going to slip schedule or spend more money. The like tos we're only going to get to if everything goes well and we have a little extra time. And finally, who can we afford to ignore? For example, we're probably going to ignore the Tootsie Roll salesman and the Slurpee salesman. Doesn't mean we ignore their requirements, though. We're just ignoring their direct involvement in requirements engineering processes. We're not going to go ask them. However, when we go interview the owner, we may need to ask them, or going and talking to the attendants, we may need to ask questions that are going to help us elicit requirements associated with those other stakeholders that we're ignoring. For example, we might end up with requirements about putting some kind of advertising tag out at the pump. You've probably seen those where while you're pumping the gas, some kind of advertisement is playing either across the little LED line, or some of the more modern ones even have a television screen that they're doing. Now, that they play advertisements in. Now, this gets back to not all stakeholders agree. I don't particularly want to watch commercials while I'm pumping gas, but, so you're prioritizing your stakeholders. Who are you going to listen to? The third step here is, once you've decided who you want to involve, who's going to represent that stakeholder group, when are they going to be involved, how are they going to be involved, what priorities are they going to have? Now, who's going to be involved? This may be a single representative. For example, the Agilist, if you're doing Scrum, has a product owner. The product owner represents all of the other stakeholder groups, and the stakeholder groups come to the product owner interacts with the development team. Others, you may have, George over here, who's third-generation gas station owner, owns 30 of them. Maybe he's representing all the gas station owners, and you're going to involve him in the process. You can also do some kind of sample. For example, I'm going to go sample and do interviews with 5 attendants, gas station attendants. Or if your group is small enough or important enough, you may even do an exhaustive where you're going to go talk to everybody. Like the single procurement officer is an easy person to go talk to. It's an exhaustive representation. When in the process, and we'll talk about different requirements activities when we get to the how section, but are they going to be continuous through the whole process? For example, the product owner is involved in all the requirements processes, or you may have, for example, the owner of the gas station actually on the requirements team, where they're helping define the requirements, specify the requirements, analyze the requirements, and even verify the requirements on an active team member. Or you're going to need them at specific times. I'm only going to go interview during elicitation the gas station attendants. Or I'm going to have a specialist in security that's on call when the team needs them, and I'm only going to need them when I ask questions. How? Again, you're going to have experience-based people. You're going to go interview. You're going to involve in focus groups or facilitated workshops, or you're going to go show them things like mock-ups, prototypes, simulations. Specifically, how are you going to involve them? And again, prioritize your stakeholder groups so that you can think about who you need to pay attention to. If the owners disagree with the attendance, who wins? Well, the owners are higher priority. However, if the regulators disagree with the owners, the regulators are higher priority. And this is especially true when you get into that group of like to includes. You want to prioritize them, so you be sure and talk to the most important ones first if you have limited time. When are requirements involved in the life cycle? The answer is throughout the life cycle. Early on, your primary focus is going to be on developing the requirements. Now, this happens to be a V model. No matter which life cycle model you're using, you're going to have to get the requirements before you go implement the product. Even the Agilists do this. They go get the user stories, drill that user story down to more refined user stories, and drill it on down as they are implementing the product. So early on, you're going to be doing and focusing on requirements development. Once you've developed and baselined your requirements, you're going to be managing them throughout the process. However, if any change happens, you may go back to requirements development again for those changes. Re-baseline, remanage them. The later cycles of phases of the life cycle are going to be focusing on testing your product against that requirements. But notice the arrows coming across. As soon as you have your stakeholder requirements, you can start validating and writing your acceptance test cases. In fact, the sheer act of writing them can help validate the requirements and make sure they're right long before you've got a product to execute. I have actually found it beneficial as soon as I start having stakeholder and product level requirements to start thinking about how I'm going to test that. In fact, if you go back to the user story, a big part of the user story is the acceptance criteria that's being defined for each of those. Do we need to test to make sure that that requirement is being met? So when requirements are going to be important to you throughout the life cycle with different emphases at different times. The how. How software requirements engineering works. There's two major process areas according to the capability maturity model. There's the requirements development and requirements management. Carl Wiegers breaks requirements development down into four major activities. The first one is eliciting the information from all your stakeholders, going out and interviewing them, getting them participating in focus groups, etc., gathering the information that you're going to base your requirements on. That flows into analyzing that information, seeing how it fits together to make a whole set of requirements, looking for gaps, looking for conflicts, looking for areas that need more clarification, which of course loops you back into doing more elicitation if you've got gaps or needs for clarification. Then you write it down, however you specify it, as entries into a database, as user stories up on a board, on Post-it notes, as a requirement specification document, one or more, however you've decided to do it, and you validate that specification and make sure it's right. Of course, during validation, this may be done through peer reviews, through writing test cases, through doing additional analysis. However you do the validation, that feeds back into defects that are found or requirements that may be ambiguous that need to be rewritten. It may flow into the need for more analysis. It may flow back into identifying defects, gaps, areas for clarification that send you all the way back to requirements elicitation. Notice this is a very iterative process. It's not a do all this, then do all this, then do all this. In fact, typically, in many cases, I do all of this at once. If you have a facilitated requirements workshop where you're bringing the right people into the room, you can elicit, analyze, specify, and validate the requirements as a team right there in the room. One of the big advantages of doing that. Or I can go interview George, and based on what he says, I do some analysis. Maybe I write a use case. I go back and validate that by doing a one-on-one walkthrough with George to make sure I've got everything. Then I go talk to Cindy, and I fit what Cindy told me in with what George told me and do some more specification. Maybe I go take it back to both George and Cindy and do a little one-on-two validation, whatever's appropriate, until we are finished. Now, let's talk about what finished means here. Give up now. Your requirements will never be perfect. The question is, are they good enough for the team that's building the product? We're not trying to build something that we can take out to Simon, pick an individual off the street, say, here, Simon, go develop this for us. We got to think about, again, our key stakeholders. Is this document clear enough, unambiguous enough, complete enough for the development community that's going to develop it, the acquirers to understand what they're getting, etc. So always think to that team. And at that point, we're going to draw a line in the sand and say, this is the requirements to our best understanding now, and we're going to baseline those and start building the product. That's when it flows into requirements management. Requirements management is all about establishing and maintaining that agreement with our stakeholder community that these are our requirements the best we know them today. Then controlling that set of baseline requirements so unauthorized change isn't happening. Nobody's just calling, Cindy and saying, hey, Cindy, would you change this for me? And she just goes off and changes it. Because if Cindy, the developer, changes it, the testers don't know about it, so they don't know to test it. So it goes out without being tested. It fails in the field. The user looks it up in the documentation to find out what's going wrong. It's not there because the tech pubs people didn't know about it. They call the help desk. The help desk people never heard of the feature. Folks, requirements management is not about inhibiting requirements change. It's about facilitating communication about those changes to make sure that all changes are authorized by the appropriate people, that they're planned into the project with the appropriate amount of resources and people assigned to go do the work, that everybody that needs to know about it knows about it so it can be implemented in all the products that are going to be impacted, not only just the code, but the design, the requirements, the project plans, the test cases, the documentation. So all of that can be kept in alignment and consistent with each other. And folks, it's about negotiating new commitments if the impact of that requirements change is big enough that you need to shift schedule, change priorities, whatever. And of course, if requirements do change, that may feed back into doing more requirements development to elicit, analyze, specify, and validate the new or changed requirements, which causes you to rebaseline. So this is, again, an iterative process. You may, while requirements management is used throughout the development process, you may have to come back and revisit requirements development periodically. Now, I'm not trying to dictate waterfall either. Even if you're the Agilist and you're just going to look at one requirement or one or two requirements at a time, i.e. stories, you still have to do requirements development, baseline those stories, agree with your stakeholder community on what those are before you go development. Then you can do the next set and the next set and the next set. So this could be a very iterative, incremental process. But you've got to develop the requirements for even that one little story or that one little piece before you can go build it. Now, I've alluded to some of this, but there's many different techniques for eliciting requirements. I have a full 3-day class on requirements engineering, and we spend a lot of time on these techniques. But you can interview your various stakeholders, both internal and external. I actually like to go to help desk people when I'm looking for usability requirements. Go talk to the help desk people. They know what's bothering the customers out there. They know what the customers are calling in and complaining about. Focus groups are where you bring homogeneous sets of users together. The family car drivers would be one focus group. The owners or attendants would be separate focus groups. And either show them a prototype or talk to them about the existing system. What do they like? What don't they like? And it's purely information gathering. These are not people that have any authority to say that has to be a requirement. You're just simply gathering information about what the requirements might be. Facilitated requirements workshops are different in the fact that these are a heterogeneous set of stakeholders. You're going to bring representatives from multiple stakeholder groups together in a facilitated meeting and literally create requirements work products. For example, you might create an analysis model from your interviews. You might even use this to come up with a complete set of stakeholders, or you might write use cases in these meetings, whatever that facilitated workshop is. But these are your decision makers. These are people with authority to say, yes, that's the way we want the product. And you want it to be heterogeneous, so that you've got people from the development community, from the acquirers community. It provides a lot of information sharing. The advantage of this over interviews, I go talk to Sam over here and get information from him. Then I go talk to Carol, and something Carol says contradicts something that Sam said, so now I've got to go back to Sam and talk to him about what Carol said. And if Jay over here would have just heard something that Carol said, then he'd have thought to tell me something that he forgot to tell me because he didn't hear what Carol said. If you can bring all these people together, typically you get a higher quality product. There's a great book called Requirements Through Collaboration that talks about these facilitated requirements workshops. Of course, not all requirements elicitation information has to come from talking to people or bringing people together in groups. Your regulations, your laws, your industry standards, go look at the actual documents and get a lot of information there. Your product literature, yours or even your competitors, go see what's being done out there. Now be careful, folks, don't copy look and feel or patented or copyrighted information. That's not what I'm talking about. But you can learn a lot about what's going on in the industry and relate to that. I actually had a manager once give me the marketing document on a product that was yet to be built, and he'd highlighted the word automatic. And he says, Linda, there's your stakeholder requirements. Every place it says automatic, that's what your software needs to go do. Process documents and other work instructions. If your system is supporting, for example, the pay at the gas, again, if you have process documents or work instructions related to how the attendant does their job or what the owner has to do as far as reports to corporate management or other processes. In this day of Sarbanes-Oxley, there's more and more well-documented processes out there that can be useful to you to understand how your user, how your customer community functions in their jobs, and how your product might help support that. Change requests, problem reports. I already mentioned going and talking to your help desk. Go look at help desk reports. Especially ones I like to look at is ones that are reported as operator error or works as designed. These are areas where somebody thought of something, they cared about it enough to call in and report it. So they can be ripe with information about things that the customer may find difficult to use, where you can make them more user-friendly in the case of operator errors, or areas where you might find some exciting things if you had an enhancement request. Always, always look for reports or other deliverables out of the current system, even if the system is being done manually today. An example I like to talk about there, one of my customers is a bank, and they were automating how the online website where the customers could go in and look at their canceled checks. And you look at the front of the check and it's oriented horizontally, and then you could push a button and flip it over, and the back of the check was also horizontal. Well, the back of the check is actually oriented vertically rather than horizontally. And once they actually saw the system, everybody's tilting their heads sideways, get a copy of it or get a report that's coming out of the current system, and go use that in a focus group or an interview and say, what would you change about this? What information on this is valuable to you? What other information do you need? What information is here that's just in your way, etc. So look at those. Whenever possible, I like to go observe the site. See where my software is actually going to be, or where my system is actually going to be. Have you ever been to one of those pay-at-the-gas pump systems where you can't read the display in the bright sunshine? It's like, where do they think these systems are even going to be? Somebody didn't think about the actual environment. And this can, in fact, impact software requirements as well as hardware and other requirements. So think about that environment, or even try to simulate the environment if you can't visit the actual site. Look for questionnaires, surveys, if you have customer satisfaction surveys, marketing surveys, other survey instruments. There can be a wealth of information there. Analyze your competitor's product or benchmark best practices. When I go do user interfaces, I always spend some time out on the net, just wandering around to some of my favorite sites or least favorite sites. What do I like about that site? What's user-friendly about it? What don't I like about that site? I actually went to a site not too long ago where I needed the information. I really wanted it. It was a good report. I was trying to read this thing, but it was a bright blue background with fluorescent green letters. And after reading it for just a few minutes, I swear the letters started swimming on the screen. It just was not the right color schema. So think about, what do you like, what works. The older I get, the larger the font I want. I've been to websites where the font is so tiny I can't even read them. I bought a new system not too long ago, a new application for my website, and I went to go watch its tutorial. And its tutorial, the letters were so tiny that even on my 21-inch screen, I couldn't read the tutorial information. It's ridiculous. Now I'm old, but I'm not that old. So look at those. Now, hopefully you never have to reverse engineer your own product, but many of us are stuck with old legacy code. And we literally have no requirements for the older version of our system. Or no documented requirements. My recommendation here is, every time you touch a section of it, reverse engineer that section and kind of patchwork quilt it back together. Don't try necessarily in getting all the requirements, but get all the impacted requirements as you're changing and adding new things. Eventually it will build up. Use cases and storyboards are great mechanisms. I already gave a webinar not too long ago on use cases. That webinar is posted out on my website if anybody's interested. It's westfallteam.com. And don't forget your human factors. Think about how people want to or need to use your system. So these are all different elicitation techniques that you can find more about. This is just an overview webinar, but so I've just given you some pointers to things. Requirements analysis. Folks, use models. Now, many of these models you're probably used to thinking of as models for you doing your architecture, your detailed design, but they can be moved up to give you pictures of what the software has to do by raising it to a higher level of abstraction. We've already talked about the use cases, class diagrams, sequence and activity networks that come out of the object-oriented world. Your data flow diagrams, entity relationship diagrams, state diagrams that have been around as longer than I've been doing software, and I've been doing it for 35 years. And even models that come out of other activities like decision trees, process flow diagrams, event response tables. All of these can be useful in analyzing the requirements, looking for those gaps, looking for areas that need additional clarification. When I teach my requirements engineering class, one of the examples that I put up is an activity diagram of the pay-at-the-gas pump system. And I just discuss what an activity diagram looks like, and then I do a little exercise that says, okay, tell me the defects and with this diagram. And within about 5 minutes, they have usually in the double digits. You know, there are 10 or more. I've had as many as 20 different defects identified in 5 minutes of things that are either missing or wrong with that diagram. I submit to you that nobody could take a set of written out verbose requirements and find in 5 minutes that many defects in it. A picture really is worth 1,000 words. The other advantage with these models is that by simply adding more detail and more detail, they transition from requirements into design as you add the how information as well as the what. And they can act as illustrations in your requirements document, help people get that bigger picture, help them see how all the individual requirements fit together. So one of the big ways I do analysis is using these. Now I don't use all of these, pick the right model for the right job. For example, if I'm doing relational database requirements, I go to entity relationship diagrams. If I'm concerned with flow of control, I go to an activity diagram, etc. Pick the right tool. Another way of analyzing your requirements is just to use prototypes. Now, folks, this is also a great way of eliciting information. Use the prototype, show it to them based on what they've already told you and say, is this what you really want? That validates them. Or how would you change it? That's eliciting new requirements. So prototypes are great for eliciting and analyzing and validating. So you get 3 bangs for 1 buck. Now this doesn't have to be full-blown code. When I prototype user interfaces, I usually use PowerPoint. I can actually make the screen look just like the user interface is going to look, even buttons that they can click on that are hyperlinked to other screens, i.e. other slides in the presentation, so that it looks very much like the same look and feel, but I can always hit the escape key and say, look, see, it's just a PowerPoint presentation. It's not the software. I've actually had it where I went and prototyped a down and dirty version of the software. They say, look good to me, when can you ship it? And as we all know, 90% of the software is all the error codes and error handling and robustness behind that user interface false front. But it looks good to them, it looks complete to them. So interfacing using, prototyping using PowerPoint, I've found a useful tool to me. Also part of analysis is prioritizing your requirements. What you want to do here is understand what's most important to your customers and build that first. Even if you're using the traditional waterfall method, if you start running out of time and start doing what's called rapid descoping, i.e. at the end you're trying to pull stuff out that's not finished, much better that be the lower priority stuff. I'd rather be 100% done with the 70% most important stuff than be 70% done with everything and have nothing that's shippable. Or I'm pulling out important stuff because it's not done yet because I did the easy stuff first, which wasn't as important. So you want to prioritize these requirements and work them from high priority down, even if you're doing waterfall. Of course, the Agilists, that's a built-in part of their process. It also helps you balance the scope against the schedule, the staffing, the cost, and the quality goals. Have you ever had them say, we've got this marketing window we absolutely have to meet. You only have 6 months to do this 2-year-long project? Well, that's just not realistic. This is how we end up with a mess. So what we can say is, in that 6 months, these are the high priority requirements that we can get you in that 6 months. Do the balancing act and say, if you want anything more than that, then you're going to have to give me more time, but I can make the marketing window with this. So it allows that trade-off. As requirements change happens, it also allows us to take new higher priority requirements in and take those lower priority requirements and move them to the next iteration or the next increment of the product potentially. It allows us to provide the highest possible value at the lowest possible cost in the lowest amount of time. Now, folks, not all systems can be done incrementally. Nobody wants an incremental development on a missile guidance system. On the other hand, many, many software systems that we build, we can prioritize the requirements and do them incrementally as appropriate. It allows us to deliver that high value functionality sooner. The lesser value functionality can be in future releases. So one of the parts of requirements analysis is deciding, can we prioritize and work our requirements that way? And if the answer is yes, to go ahead and do that. Specifying the requirements, some good practices from Carl Wiegers: adopt a requirement specification template. Now folks, this does not have to be a template for an entire requirements document. I have templates for just doing, what does a good safety requirement look like? Here's a template. It's just a little fill-in-the-blank thing. Identify the source of every requirement. Already you're going to start doing your traceability matrix and trace each requirement back to its source. Take the product level requirements, trace them back to the stakeholder requirements, trace them back to the business requirements as appropriate. The reason being is later on, if you don't have that connection, somebody wants to come in and change a requirement. It looks perfectly reasonable to you to change that requirement. You don't see a reason why you wouldn't, so you go ahead and allow it to change. And later on you realize that it was the implementation of a government regulation and you're no longer meeting the regulation. Without that traceability, you might forget that that requirement is associated with that government regulation or overlook it. By having that documented in your traceability matrix, it becomes obvious. Label each requirement, give it a unique identifier so you can reference it. And I don't mean it's the third square bullet under the fourth round bullet under paragraph 3. If you've got sub-bullets, I love bullets. That's good engineering practice. But even there, sub-label them. This is requirement 392.1.3, whatever. But have some way of uniquely identifying. And don't forget to write down those business rules, again, so that you don't forget them as you're changing things and so that you can trace back to them. Some techniques for writing a good requirement: short, direct, complete sentences. Folks, this is not the great American novel. Take everything you learned in English composition in college and throw it out. This is technical writing. Short, sweet, active, not passive voice. By its very nature, passive voice is more ambiguous. So make them easy to understand. This literally is see Dick, run type terminology. Be consistent in your terminology. I have actually seen requirements documents where the same person, for example, the driver coming up and purchasing the gas, in one part of the document they're called the driver, then they're called the purchaser, then they're called the customer, then they're called the user, then they're called the buyer. 5 different terms to mean the same entity. How confusing and ambiguous does that become for the development community? Pick a term and use it consistently. Don't call it the transaction information one place and the transaction data someplace else and the data about the transaction in third place. Pick a term, define it, use it consistently. It's going to remove a lot of ambiguity. And worse still, it'll keep you from making the mistake where I've seen the customer is the person that buys the gas in one part of the document. Someplace else, the customer refers to the person that's buying the software system from you. So you have the same term to mean 2 different entities. That's even worse. Remove as much ambiguity as possible. Now, by its very nature, the natural English language is ambiguous. Excuse me. But at least make sure that everybody, all your key stakeholders, understand the meaning of that term. Right now, everybody think of a knife. Get a picture of a knife in your brain. Okay, how many of you had a dagger, actually a knife, in your brain? Some kind of weapon, switchblade, dagger, knife, weapon. How many of you had the knife, fork, and spoon like you had your silverware that you ate dinner with last night? Are there any cooks out there? If I just said bring me a knife, how many of you bring me a butcher knife or a paring knife? Do I have any Boy Scouts or, the Swiss Army knife or the folding knife? Do I have any artists? Is it a palette knife? Any doctors? Is it a surgical knife? There's so many different knives out there, But do we have an agreement now within this particular setting? One of my favorite examples of an ambiguous requirement was one Texas company writing software for another Texas company. And the requirement said all reports and screens will be bilingual. What two languages did they pick? One Texas company writing software for another Texas company? Of course, English and Spanish. In acceptance testing, they found out the end user lived in Quebec. They were a subcontractor. Folks, can you come up with more than one interpretation of what this means? Drill the requirements down to the appropriate level of detail for the audience. And this is going to depend on the audience. If you've got senior people building this product for you, and this is the 37th time they've done a password function, you can leave it at very high level. If you've got more junior level people, or the more geographically dispersed, if you're sending your requirements to the Pacific Rim to be implemented, you're going to need to drill them down to more detailed information, because you don't have the, hey, I can holler over the wall and ask a question. Use those models, graphs, tables like we talked about from analysis to help illustrate your requirements, make them more understanding. Include one and only one requirement per requirement statement. My judge of this is, would I test it as a single set of tests, or am I going to break it apart and test it separately? If I'm going to break it apart and test it separately, it's two requirements. I actually try and get an electronic copy and search for ands and ors. And when I see ands and ors, I say, is this a good and, i.e., the information will include this, 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 and this. That's a good and. Or one that's an and that's chaining multiple requirements together in a long statement. Already talked about uniquely identifying each one of them. Be as specific as possible. Again, don't say knife, say butcher knife, say whatever's appropriate. Avoid pronouns in your requirements document. He, she, it, they, them. The problem is, when you come back and try and modify the requirements document later, those pronouns can cause ambiguity. For example, the card reader does this. It does that. Later on, I come back and modify the first requirement. The card reader and the pump do this. It does that. Now, which is it? So, if you'd have written it, the card reader does this, the card reader does that. By modifying the first one, you would have never introduced that ambiguity. The card reader and pump do this, the card reader does that. Make them measurable, make them finite. I'll talk more about those two when I get to requirements validation here in just a couple of minutes. Requirements validation. Do lots and lots and lots of little peer reviews. As soon, every time you do part of the requirements, take them back. For example, I do an interview, I already mentioned this, create a use case from that interview, go back and show it to that person. Do a little one-on-one walkthrough. Or throw it on their desk and let them bleed red on it, whatever. And I can do this multiple times, lots of little informal peer reviews. Then once I have the entire set of requirements, I want to make sure they're consistent, they're unambiguous as a set, complete as a set, consistent as a set. Then I want to do the full-blown inspection here. This is the biggest bang for your buck to do those full-blown inspections. If you don't do it anyplace else, consider doing it for your requirements document. Now, I know of no way of making sure your requirements are complete, but here's my checklist anyway. Have I got all the functions? Well, I go back to thinking about all my different types of users, the normal users, the power users, the novice users, all of my various stakeholders, both friendly and unfriendly stakeholders. Unfriendly stakeholders are people that you want to be unfriendly to, like the hacker or the credit card thief that's trying to break into your system and steal credit card numbers or use somebody's stolen credit card. Have I handled all the business rules? Go back to those models, and for every element of the model, have I defined appropriate requirements for those features and functions? Go back to that checklist I gave you earlier of quality attributes. Have I defined all of those? All of my external interfaces, all of my data. One of the ways I look for completeness of data is I look at my requirements for nouns and say, is that noun a piece of data in my system? If so, then I go to the CRTL acronym. Do I have requirements associated with creating that data item? Do I need them? Do I have ones associated with updating that data item? Do I need them? For example, am I going to update the gas price? Well, yeah. Do I have those requirements defined? For reading it, for deleting it, for listing it. Again, do I have not only the data items, but do I have the appropriate features and functions associated with that data item? Have I considered all my design constraints? And this is where I ask myself one last time, does it have to be a design constraint? You know, leave to the development community as much options as you can. Sometimes people will say, I want to push a button to get this, simply because that's the way they've always done it in the past. But it could be a touchscreen, it could be voice activated. You know, ask them, does it really have to be? Give them options, and don't put unnecessary constraints. Have you considered operational adaptability? Are there different system modes? Do you have to consider future expansion? So that's my checklist for completeness. So as a whole, once you've got the requirements document, look for completeness. Look for internal and external consistency. Internal consistency, again, are you using the same terms to mean the same thing, like we talked about already? Are there any requirements that contradict each other? External consistency, do the product requirements, are they consistent with the stakeholder requirements? Are they consistent with the business rules? Are they consistent with the business level requirements? Is it modifiable? First of all, get rid of those pronouns like we talked about. Put each requirement once and only once, and just reference it every place else. Don't use auto numbering to number your requirements or your paragraphs, because then your references get messed up if you add anything. And is it compliant with the standards? Whatever standards you're using for your models, for your specification, whatever. Then look at each individual requirement. Is it clear and unambiguous? Can you think of more than one way of interpreting it? Is it concise? Clear, action-oriented, non-passive voice sentences. Now, I told you I'd come back to finite and measurable. When I'm looking for finite, many times I look for LY words and IZE words. You're going to minimize, I'm sorry, that's measurable. Excuse me, measurable. It's IZE words and LY words. It's going to be user-friendly. It's going to be done quickly. I'm going to maximize the screen. I'm going to standardize the operation. Those are just not measurable. Put specific measurable values in. For finite, you're looking for words like all, always, sometimes, usually, included but not limited to. The one word that never belongs in any requirements document, etc. I'm going to do this, etc. Folks, don't let them do that. Just turn it into a TBD. That's much more relevant. Etc. just means I can't think of them all now, but I reserve the right to add additional requirements later on without having to renegotiate time, scope, and schedule, because I warned you they were going to be there. No. Keep etc., keep including but not limited to type phrasing out of your documents. Now, folks, not all alls are bad. You always have to ask yourself, is this a finite all or not? For example, the system will respond to all user commands within 3 seconds. That's a finite all. It's internal to your system. You know what all the user commands are. That's a good all. But the credit card will work with the system will work with all credit cards from all banks. That's an external all. Tomorrow, the Greater Bank of Outer Mongolia can come out with a new Mongo card, and your system is no longer meeting its requirements. So you'll start collecting keywords that you can start searching for. Fast, quick. Those are examples of other non-measurable words. Are they feasible? The best person to determine whether it's feasible are the designers and coders that are going to have to go implement that. Get them helping you validate requirements. Is it testable? Again, the testers are the best people to tell you that. Get them involved in the requirements. I love to get testers involved because they think differently than everybody else. Everybody else is trying to make it work. The testers are trying to figure out how to break it. So they're going to find missing requirements around error handling and things like that. that the rest of us might not think about. Always make sure the requirements are traceable back to their source as part of validation, and make sure they're value added. And this is one where you're going to have to get the development community to work with the other stakeholders to determine value added, because you got to know how much it's going to cost and what benefit it is to look at the cost-benefit analysis here. The other way of validating your requirements is as early as possible write your test cases. Now obviously you're validating the requirements as you're actually executing the test cases later in the life cycle. But as I already mentioned, move those test activities up as early as possible. If nothing else, create a test matrix with each requirement, the levels of testing, the types of testing, and start thinking about how to test each of those requirements. The sheer act of doing this will help you uncover requirements like this last one, which is not testable. The system will work with all credit cards from all banks. The all there is non-finite. There's no way to come up with a set of test cases that will test that thoroughly. So test early and test often. So in this talk, we've talked about the what, why, who, when, and how, what requirements are, the various levels and types of requirements that need to be defined, why getting your requirements right is so important, who needs to be involved in the requirements, identifying your key requirement stakeholders on both the acquirer side as well as the supplier side as well as other stakeholders. We talked briefly about when requirements activities are involved in the software development lifecycle, which is basically everywhere. And finally, we briefly covered some of the activities of requirement solicitation, analysis, specification, and validation, and I briefly talked about requirements management. Now, all of this is obviously just an introduction to a much more extensive topic, but it gives you a feel for the kinds of things you need to be thinking about and learning about if you're going to be doing good requirements engineering at your company.